Today I'm going to talk about HTTP 2. And again, this is joint work with a lot of very good colleagues from Telefonica, Case Western, and CMU. So let me give you a little bit of background on HTTP 2, not too much, so Kyriakos has to do some actual work later. So those are some of the main features of HTTP 2. So first of all, HTTP 2 was standardized in May 2015, so it's a fairly new protocol. And it's basically coming out of Speedy, which is what Google was proposing some years ago for replacing HTTP 1. It has few interesting features. The first one is that it's a binary protocol, which means that you get all these nice things. You have efficient parsing. Of course, there is like some a line network footprint. It's more compressed. But most importantly, you solve some of the security issue that you had with HTTP 1. Mostly due to unsanitized strings. Then you have header compression, which has been a big problem for HTTP 1 for a while, because you have all these redundant headers which you keep sending over and over when you have multiple objects. It wasn't a problem at the beginning of the web when you have few objects, but now that the average web page is composed by hundreds of objects, it actually becomes to be a problem. And then the most important feature is multiplexing, which means that now you can actually have a single TCP connection and use multiple streams. You don't have the problem of head-of-line blocking that you have on HTTP 1. You don't need to open so many TCP connections in theory. And then there are some more futuristic features like a priority server push that we didn't look into because they're not really adopted yet, and I think Kyriakos might actually talk a little bit about it, so I'm not going to do work for him. All right, so what do we do in this paper? So we study HTTP 2, so we monitor HTTP 2 adoption. Our goal was to monitor HTTP 2 adoption in the web, grow as big as possible. So what we do is that we do it on the Alexa top 1 million every day. And we started in November 2014, and we increase that list every day. So now we're doing 2.2 million websites. We also do some content and performance analysis. And we do that, of course, on the subset of websites that they actually support HTTP 2. And then we build a cool website, which I'm going to show you later. So why do we do that? So first of all, we're very curious to understand who is behind HTTP 2. And we had the feeling that this was a very unique opportunity to try to understand how a new protocol is adopted. We all know what happened with IPv6. And we started thinking, if we can actually catch it fast enough, even before this happens, it would be interesting to see how in the modern web a new protocol get pushed out. So we feel like this was a very important contribution. Then of course we want to know whether it's bringing any benefit, because there was a huge discussion around Speedy, whether it's useful or not and in which condition. So we just want to go out in the wild and see whether HTTP 2 is actually doing any good. And then if you are familiar with what is happening with HTTP 1, you know that in order to make it work and work well, there is a set of hacks that are actually being done, like for example, domain sharding or inlining. So you want to try to understand what happens when a website is switched from H1 to H2, whether its content change and, for example, these hacks disappear. There are so many other questions that we actually look in the paper. I'm not going to talk about all of this in the talk. You can go and check it out. You can also go on the website. For example, there was a huge discussion about HTTP 2 in the clear, whether you should support such a feature, or you just should support it in an encrypted way. They went on and on discussing, and of course now you can support HTTP 2 in the clear, but most browsers actually say they're not going to support it. So it's kind of interesting to see what the servers are actually doing. So how do we do this? So we have three phases, phase 1, phase 2, and phase 3. So we start from the Alexa top 1 million list. And what we do is that in phase 1, we try to understand what are the sites out there that announce support of HTTP 2. There is a specific protocol for doing that. We implemented that. We use a very simple tool to just go very fast and check all these websites. So then we have phase 2, which is trying to understand, you're a website announcing HTTP 2. Are you actually supporting HTTP 2? If I run an HTTP 2 client, can I speak the protocol with you? Are you going to answer or not? And then after that, we have what we call phase 3, which is trying to run some more complex experiment and try to understand, to give an answer to all the questions that I told you before. For example, for this specific website, is HTTP 2 giving benefit or not? So let's go through all the phases now. So phase 1, the main challenges are scale and speed, right? I said I want to do the top 1 million from Alexa every day, and this is challenging. So the way we solve that is that we build a very lightweight tool, which is a bash script that you can run from how many machines as you want. And what it does is basically just doing ALPN and NPN negotiation. So it's going to our website, speaking the right protocol, and say, hey, do you support HTTP2? We also do some more stuff. For example, we test for quick and other things. But for this work, this is what I'm focusing on. And in order to reach the scale that we need, we're using Planet Lab, which is about 1,000 nodes. Not really, you cannot really use all of them, but on a good day you can use probably 100 or 200. So we deployed it right there, and the way we did it is we have a tracker machine running in our lab, which is taking care of assigning to each Planet Lab machine a task, which is basically crawling 100 websites and see whether they support H2. And then whenever a machine goes down, you have to reassign the task. You need to make sure that you're using the right machine and stuff like this. Remember, this has been running now for 1.5 years, so it has to be stable. We need a way to deal with all the Planet Lab issues. So then we have phase 2, which has a smaller scale, at least for now, because we're focusing on the website using HTTP2. Of course, the challenge was that over 1 year, the number of websites, of course, is increasing, and we have to keep up with that. So in this case, what we want to do is we want to go on that website, fetch the root object using HTTP2, and just try to see whether this is possible, or we're getting an error, we get redirected to HTTP1 or something like this. So for that, we build another tool, which is called H2 Lite, which is just using Node.js HTTP2 library. This is not like, for example, a realistic tool to estimate page load time, but this is not what we want to do here. Here we just want to make sure that if a website is announcing HTTP2, is actually supporting it. And this is running just from a bunch of machines from Telefonica in our labs and CMU. So then finally we go into what I think is the most interesting part, which is phase 3. It's a small scale now, right? Where we start from 1 million, we find the website supporting H2, the one that really support it, everything is working fine. And then for this one, we're testing performance. So in this case, we're using Chrome. And the reason why we're using Chrome is that we play with a lot of headless browser like Phantom.js. First of all, Phantom.js, as far as I know, is not supporting H2 as of today. You have to use something called Zombie, which has issue with JavaScript. Performance are not comparable with Chrome. So we ended up spending more time and making sure that we could build a tool which is fully virtualized. We don't need the natural screen. We have a virtual screen. We have our what we call the Chrome loader, which is just a Python tool to interact with the Chrome developer interface, so we can get all the information we need. And we're using a real browser, which is giving us some sort of guarantees on the page load time, and you'll see later about it. So this is running from all the location we have, Telefonica, CMU, and Case Western. And in case of Telefonica, we actually have physical access to the machine, so we can stick in there some 3 and 4G dongle and play also with the access. All right, so let's see if I can show you the website. Okay, so this is you can actually go there, and there is more. But what I want to show you is the HTTP2 adoption, which is, as I was saying, we started in November 2014. So this has been running now for more than 1 year. What is interesting to see there is, at the beginning we had pretty much no adoption, right? I mean, this is what we think did pretty right. So we started at the right time when there was not actually a deployment of HTTP2. You see there are like 600 websites announcing HTTP2. That's just Google. Interesting event that you see in January 2015, there is like no adoption of H2 at all. Basically Google turned it off because they were solving some issues they had. They actually announced that on their blog, and then they came back about like a month later. Then nothing happened for a long time, and that was really frustrating for us because we're expecting to see some adoption and being able to do some more measurements. And then finally start to pick up, right? So what we see there, yeah, thank you. What we see there is, for example, is one of the first jump, and this is when Host, which is like I think some cloud provider, they turn on HTTP2 for their customers, and so then you see this jump. Then some of these things are due to the fact that new web server implementation are coming. So then you see that there is more adoption, and then the most important jump is right here. This is Cloudflare. They activate HTTP2 for all their free customers, and this is like 60,000 websites, and that was a huge impact on our measurements. Now some of the fun stuff. This is SICOM deadline. I had to turn on basically I stopped using Planet Lab for this, and I use it for my SICOM submission. And this is Kyle leaving Case Western, and we lost access to their machine. So we had to kind of regroup a little bit, and now we moved everything to other machine. So that's due to us, not due to some HTTP2 stuff. Okay, so what about content analysis? So as I was saying before, we're trying to understand whether there is a difference between a website using HTTP 1 and using HTTP 2. And specifically, we're trying to understand if all the hacks that are being used for H1 are still being used for H2. So here I'm just going through one example, but in the paper we actually do a bit more, so you can refer to that. So what we're looking here is just the distribution of the number of domains that you connect to when you use H1 or H2, right? It's a distribution because, of course, it's done across about, for this result was 10,000 websites in this very specific example. So the mean is 18 domains. So, but what is more important is that there is actually no difference between what is happening with H1 and H2. And this is actually representative of what we saw before. The adoption of the new protocol is due to the fact some big provider, they turn it on for you, and in some cases you might not even know. So you might be hosting your content, you're using Cloudflare. Cloudflare is now offering that service for free, and you're not going to go and change your content, right? You keep serving the same content just with the new protocol. So this is very important because that means that many of the H1 hacks are still there, and they might do good or bad to HTTP2. We actually don't know. The same thing is true for the other plot. What we're looking at there is actually how many objects you have per domain. You see this is very small. On a single domain, you only have like 3 objects. So this is suggesting that either there is some sort of domain charting being done on purpose because H1 is getting some benefits out of it, or just because the web is like this, and you know, you might need to fetch content from many external parties, right? I mean, CSS, some advertisement and stuff like this. Why is this so interesting? This is interesting because one of the main features of HTTP2 is that you can actually use a single TCP connection, right? So this is what people have been studying also when they were referring to Speedy. They were assuming you're moving from H1 to Speedy, you're going to have a single TCP connection. And they actually were saying this is going to be bad because now if you are on 3G and 4G and you start having some losses on that link, then you're going to have problems, right? H1 is going to do better because you have multiple TCP connection, so that's actually going to be better in a lossy environment. So this is true, but this is not what we see in reality. And whether this is due to the fact that content is not optimized for H2 or is just a mistake, that is not something we can know. We're just passively measuring. But this is what is happening. So for example, if you look at and I didn't want to go through the details of the plot, but if you want, you can check it out. You know, on average, of course, HTTP2 is requiring less TCP connection, actually half. But it's very rare that you're actually going to use a single TCP connection, right? And in many cases, you're actually going to have like 20, 30, or even 100 TCP connection. So this is different from what people were actually expecting. So let's see now the most important plot, performance. So is actually HTTP2 faster than HTTP1, right? So the answer is that for 75% of the website, it is faster on average, but still there is like 25% of the website that are suffering. And it's very interesting to see that while I look at this plot and I say, hey, H2 is great, somebody from Akamai would be like, yeah, but what about these guys? I cannot turn on that feature, and then these guys are going to actually suffer because of that. So what is important here to notice is that performance is actually getting better as you go from fiber to 3G and 4G. And this is completely different from what we saw on previous paper, specifically on Speedy and a little bit on H2. Of course, this could be due to the fact that we're running our experiment from Telefonica, where we actually have very good connectivity. We're trying to extend all these results by getting access to more nodes and try to have a little bit more diversity. And now I'm going to introduce something which I found really fun. So when we start doing this, we start wondering, how do we actually measure page load time? We measure page load time in the same way as everybody else is, using onload event. But the onload event is not really representative today because basically every time that you're going on a web page, most of the content is composed by JavaScript, and then you have JavaScript, loading JavaScript, and getting the actual object. So the onload event might just not represent the actual user experience. So how do we go from page load time to actual user experience? So what we started doing, and this was really motivated by this work, is to build what we call the user perceived page load time. So we want to try to understand how you guys perceive page load time, right? And how do we do that? So we build a tool. We actually extend phase 3 with video recording, right? So now we can run phase 3, play with H1, play with H2, and at the same time record some videos of what is happening on the screen. And then automatically build a website where we're going to post these videos. And we're just going to go around and ask people, which one do you think is faster, right? So we actually did it, and hopefully it's going to work because we've been up all night for this. But this is how it looks. Okay, so what I want you to do is play this with me right now, and then if you can do it on your laptop, it would be nice because we can actually get some data. All right, so the way this works is that this is actually explaining you what we're doing. You know, we're doing this page load time test. We want you to tell us which one was actually faster, more usable, whatever actually resonate with you better, right? So we begin the test. We need to get some information. Let's say I'm a male, 33. You can actually use it as you're supposed to use it, which means that you're going to put your country of origin, all this information. I actually pre-selected a set of videos for you for this demo so that we make sure that we don't show porn and something that is not going to work, right? Because, you know, making sure that what we're doing now is we're just crawling the top 100 from Alexa, but we need more like sanity check. So, all right, so we have PAM demo, and let's say read articles. And hopefully Google is not going to complain. I'm not a robot. Okay, I need to say select noodles. This is noodles, right? Noodles. That's it? Yep. All right, verify. Ah. More? Yes. Okay. As you can see, we spent a lot of time doing that, and now Google is complaining about the capture, right? Okay, so this is how it works. You're going to see 2 videos, and I want you to tell me which one is faster. Pretty simple, right? You're going to tell me either left or right, or we cannot tell. Which one is faster? So we select right, and we say continue. And then we're going to do it again. Which one is faster? Right. Come on. Right. All right. Right is faster.
Right again. Is right always the right answer?
No, it's totally random. So I mean, what we did here is we pre-select the videos, so hopefully I'm going to show you some interesting cases and no porn again. But other than that, it's totally random. So what is going to happen once you go and you don't put PAM demo in there is that you might get some porn. I'm sorry about it. You might get something that is going to fail because we're still debugging, but then you're going to go through the real thing. What about now? Right. Trust me, it's random. Which one is faster now? Same? No difference. Okay. So, all right. So what is happening here is, for example, look at Netflix, right? So the onload event, we're actually all agreeing, that this was faster, but in fact it was lower, according to the onload event, right? We got it right here in case of Stack Overflow, for example. Even in this case, this is really impressive because usually people cannot distinguish like 100, 150 milliseconds, so they're really close, and we did good. But then look, for example, at Microsoft. There is like 200 millisecond difference, and we couldn't notice, right? So if you look at my plot, and now you start thinking about this 150, 200 millisecond, then basically H2 saying that it's faster than H1, you cannot really, right? Because that uncertainty due to all this that I show you here might actually change completely the results. And this one we actually did good too. So, all right, we're back. Yeah, so we think it's interesting to try to understand how page load time works, and we would like you to help us. At the same time, this is still, like in a very early stage. So as a future work, we want to extend that a lot. We want to try to understand whether demographics play a role in the way you compute page load time, and hopefully come back and try to propose a better page load time metric. So there was a lot of advertisement about the new project, but I think it applies to HTTP2 as well, because it's going to give an answer on whether it's faster or not. Thank you.
So, any questions? Oh, yeah.
So you're saying domain sharding has not gone away, right, with HTTP2. So why do you think HTTP2 is faster? Because I thought the main reason HTTP2 is supposed to give you better performance because of multiplexing.
So still you're using half of the TCP connection. So what I was trying to say there is that it's faster where you expect it to be faster, and it's not slower where you expect it to be slower, which means I would expect H2 to be slower when you have a single TCP connection or a couple of TCP connections and you have a lot of losses. But this is not really happening statistically, right? So in those scenarios, we just statistically don't have it as a result. And remember, this is all passive. I can cook up a controlled experiment and show you that if I take the specific website which is using 2 TCP connection and I start dropping like crazy, then H1 is faster. So H2 is supposed to be faster because it's a little bit more compressed and is using less TCP connection. It should be more efficient in all that. And at the end of the day, this is happening. But it's also happening that where it's supposed to suffer, it doesn't suffer.
And just one suggestion about the domain sharding chart, to be sure. You're just counting number of domains.
Yeah.
Maybe it's worth looking at the IP addresses that those domains result in, because
No, it's a good idea, yeah.
Because like we might be
Sure.
using a bunch of domains, but they're actually pointing to different locations, different
Yeah,
servers.
yeah. There's-
Sharding means
yeah.
using 6 domains.
Correct.
Pointing to same IP.
Yeah. There is also definitely more we can do in the content analysis. For example, we do a little bit on trying to understand inlining and this kind of stuff, but it's not that straightforward. So I'm looking for interesting tools to actually try to automate that a little bit more. It was a lot of manual work, so we need to improve that. Thank you.
Maybe we have time for one just more question. Just one more. Okay, maybe I have a question. That's very interesting demo that you gave us. Thank you very much. I was wondering, how many users do you have in that demo already?
Well, these guys.
Okay, so we were the first.
This is as new as last night,
Okay.
and lack of sleep.
Okay. Yeah.
So it might break, as I was saying. Keep working on it, but actually what we want is to get you guys to go there, play with it. If you see something that breaks, send us an email. We're going to use your data to understand a little bit about it. The database only contains 100 websites, then I removed most of the porn that I could see, so now it's probably 80. But anyway, it's small, but it's going to get bigger. So the idea is, we're also going to show you videos where we play with delay, where we play with losses, where we change stuff, and we're trying to understand how this impacted the page load time. But at the end of the day, you are the first test, and then we're going to probably go crowdsourcing to get a bigger number of users. All right?
Cool.
Thank you.
Thank you very much again.